So good morning. My name is Martin Atzmueller and I'm really happy to be here to give this talk, and also I want to thank again for this opportunity, so for inviting me, so thank you very much. I'm at the University of Kassel, and in a minute I'll show you where Kassel is, so if you have a rough idea and you want to get some more details, I can show you this on the map. But before I start, I want to introduce myself briefly. So in my work, I mainly focus on data mining and web science. So I work on this intersection of these different data and the data analysis in these directions. So I focus on social network analysis, for example, also including offline data and online data. And this will also be the topic of this talk. And at the University of Kassel, I'm heading the Ubiquitous data mining team. So if you don't know exactly where Kassel is, okay, we are here now. And Kassel is really in the center of Germany. According to some definition, it's the center of gravity or something like that. You can look that up on Wikipedia. Yeah, but this is just one small detail. As I said, in my work, I focus on this kind of data analysis on online and offline interactions. And in this talk, I want to focus on the mining of these social interactions. So in this talk, I will skip the online. Well, maybe there will be some integration about that. There's a lot of data and a lot of analysis here. But instead, I want to focus on the social interactions between humans. So this is really about getting to know about the contacts between humans and what motivates these contacts and what is the underlying behavior, basically. And this also kind of relates to this topic of social media, because social media, you have users that are contributing something, that are generating some information or some content, and that is exchanged. And basically, you can also extend this definition of social media to some kind of sensor-based information. So let's say you have some ubiquitous sensors or some wearable sensors, and then these sensors exchange information about the behavior of humans. This also relates kind of to the social media definition, or what is going on here. So basically, what I want to do in my talk is to give you some insight or some results on the social interactions between humans, and this is the key fact. And for that, we are using some sensors. That's why I'm also at this Future RFID Technology Conference, because we are using RFID sensors, of course. And I'll show you some technical details about that in a minute. And with these sensors, we can do some quite useful things. For example, we can do proximity detection between humans or between objects also. And we can also do localization. And what you see here, this is just a screenshot of a visualization that we did. So you see different rooms and different people that are wearing these sensors. So these are the nodes, or these little dots in these larger circles, which are the rooms. And they're connected by some edges. And that is actually the communication that is going on at this precise moment when this screenshot was taken. Okay, but now, why is this really interesting? So what can you do with this kind of data? We want to understand social interaction processes. So if we collect all this data, we want to get a better understanding of what is going on in real life. So sometimes this is also called reality mining, because you collect all this data that is real world data from the ongoing processes, how humans interact in the real world. And when you then feed this back into some models or into some analysis tools, you can do a lot better. For example, for event planning, when you model all the processes, the social processes that are going on. If you want to do event detection, you can do some burst detection, for example. if you focus on the temporal or spatial information contained in this data. And you can also look at diffusion processes. For example, in online social media, there's a lot about the spread of information in online social networks. And here in this context, you can do this as well. So you look at how information spreads in this contact network, for example. This also goes to opinions. So which people do you possibly want to influence so that an opinion or some news really spreads, or how do the relationships get established? And another thing that is quite interesting is also concerning epidemiology. For example, if you're looking at some contact patterns or some social interaction in hospitals, for example, then you can try to identify situations where something is going wrong in routine clinical practice, for example. So then a very easy example is that people sometimes don't wash their hands, right? So if nurses sometimes don't wash their hands and you have some object that just measures if people do that, then this can also be a very simple and effective measure. But in epidemiology, you can also study the distribution, let's say, of artificial viruses. There was an experiment in a museum where people were wearing these tags, and then some spread of a virus with these contact patterns was studied. So how do these dynamics evolve? I mean, this is quite interesting, and if you look at the recent outbreak of Ebola, for example, then you can also see this, the relevance maybe of this study. So this is basically from the understanding side, but we can also do some applications, and I'll show you some examples in the systems that we have implemented so far. For example, you can do recommendations. Let's say you're at a conference and you want to find out what is really relevant at the conference for you. So let's say you're interested in talks, or you're interested in talking to certain people. And then if you knew which people or which talks were really relevant for you, if your system would recommend that to you, then this would be really helpful. Another thing in organizations is that sometimes you want to do some expert identification. So you want to find out which people are the really experts in some field. And this can also be analyzed or discovered from the data, from the social interaction data. And the last point is related to this epidemiology. So if you model these kind of traces of the information, that how they flow through the network, then you can also use this in certain applications. Okay, but now we come from the general framework to the outline. So this is the outline of my talk. I will start with some systems that we have implemented. Then I'll go to some analysis results and some applications on that. And finally, I will conclude and give you some outlook on current work that is going on, and also some further future directions. So for the systems, I basically want to talk about two systems. As I said, we had this scenario with the conference. We have a social conference guidance system, Conferator, which is also based on these tags. And basically there's some recommendation functionality and also some talk prediction functionality. I'll come to that in a minute. And we have also a system which is called My Group, and this is for working groups. So basically, My Group is Conferator for working groups, and this is also about enhancing the social interaction in working groups. From the hardware side, we are using proximity tags. So these are active RFID tags produced by the Socio-Patterns Consortium. And they allow you to detect face-to-face contacts and also do some localization. So depending on the number of RFID readers that you install, you basically have room-level localization. So this is quite easy to implement. As a software platform for that, we use the Ubiquitous platform. And this is also some commercial, let's say, of the platform, because this is open source. You can, if you're interested, you can download the software, and it's basically some kind of big data architecture, because we're also using that for other systems. So you have some immutable data storage layer that just stores data. Then you have individual data processors that process all the data according to different goals. And then you have the data serving. There are also different modules for privacy, data analytics, and so on, which support the system. So all the systems that we have is based on this software platform. And the hardware part are actually our RFID tags. So the goal here is to capture face-to-face contacts at large scale. And you might know that there are several experiments for also capturing this proximity or interaction data with Bluetooth, Wi-Fi, also passive RFID, but usually there you only have limited information about this contact information because with Bluetooth, for example, you cannot really detect that people are facing each other. So you have some information about co-location, so people are at the same place, but you don't have information about this, that people are really facing each other. So we take this as a proxy for a conversation. And this is where these RFID proximity tags come into play. So these are kind of smart badges. These are active RFID proximity tags. And the technical innovation is that they transmit signals on 4 different signal strengths. So they exchange the signals. And the tags, they exchange also the signals on the lowest signal strength. And the lowest signal strength has a distance of about 1 to 1.5 meters, and this is a typical conversation distance if people are in conversation. And then each tag records signals from other tags and sends it to a reader, which then transmits this to our central server. And in this way, we can collect all this data and use it for our algorithms. And this reader-based system also enables us with localization, because if you put the readers into a room, for example, let's say in this room, I would say we would need about 3 to 4 readers to cover the whole area. Then you're really, if you can split up the rooms so that you have a distinct set of readers for each room, you can really know where the different people are, depending on the packets that are transmitted to the readers. For the configurator system, we have applied this at several conferences so far. Last year we had this at the largest German computer science conference, the largest general German computer science conference, the Informatik 2013. But in the years before, we also had this at ACM Hypertext, for example, at some smaller German computer science conferences of some special interest groups. The system helps people to recall their contacts at a conference. So basically it works like that. At the start of the conference, we do all the installation, and then we offer one RFID tag to each participant. They have to volunteer, basically, and also to sign a privacy declaration that they want to participate. And after the conference, they can recall all their conversations that they had during the conference. And there is also some visualization about what is going on, for example. And the system also recommends talks. So basically, you get a personalization of the conference schedule. You have that in the system. And here is a screenshot, an example of the configurator system in Kassel at the LWA 2010. And this is basically where the coffee break is happening here. So this is at the time of the coffee break. Almost everybody is in one room, and yeah, some people are still discussing in some smaller lecture rooms. The My Group system is similar, so we have that system for working groups. We had this system running at our working group for 3 years now, so we collected a lot of data actually. So every day, each member of the group was wearing these RFID tags. So we have quite a lot of longitudinal data that you can do here. And the system, let's say, it gives you some indication what your colleagues are currently working on, because it shows the bookmarks and publications that we enter into Bipsonomy, which is another system that we use for organizing bookmarks and publications. And there's also some localization functionality, so you can find out where are the colleagues. This is just an exemplary screenshot. So here you see some bookmark of me and my colleagues. So there's some kind of timeline, and then you can see what is going on. And there's also some visualization. So this is some visualization that we had a certain event. So you see the contacts and the locations of the individual people. Okay. Now come to the second part, to the analysis and applications. And this is also related to the system. So all the data that I will show here was collected using the configurator or the My Group application. Sorry. Well, the first thing that you want to have a look at are some statistical properties. So basically, in our analysis, we're mainly concerned with the contact network of the different applications. And what you usually do, okay, you look at the degree distribution. So what is the typical degree distribution? What you would expect is some kind of normal distribution. So you have a peak in the middle, but in our case, at the LWA 2010, it also a peak at the left. And this was kind of unexpected. It turned out that these were actually the student assistants that were present at the conference. Though these didn't have too many contacts with other researchers, for example. So if you excluded them, then this left peak vanished and we had the expected distribution. And furthermore, what you usually observe in such contact networks is a power law, some kind of power law, long tail distribution for the contact durations. So at the right, you see the contact duration on the x-axis, and on the y-axis, you see the probability of observing a certain contact duration. So what you see is that here, the short contact durations, okay, this is the aggregated contact duration of the whole conference, so that short contact durations are quite likely, whereas these long contact durations, okay, this is really probably an outlier because this is almost 4 hours on the whole conference. These very long contact durations are really very unlikely. So you have this typical distribution that you get the main probability mass, so to say, in this area. Okay, well, then comes the question, how do we create these contact networks? We capture these face-to-face contacts and we say that if the RFID tags, if they are in contact for at least 20 seconds, then we say that there's some conversation. Because if people are just passing by, so one tag is just passing by another tag, then there's no real conversation probably going on. And we say that a conversation ends if there's no signal within 60 seconds after the last signal received. And then we can also create different networks according to this minimal length of a conversation. For example, we can filter contacts that are below 5 minutes to filter out all the small talk that are going on. And the first thing that we did at some conference was to check if this really makes sense. Let's say the contact network, it fits a track network or something like that. And therefore we did some community mining on this network structure to get these densely connected groups in the graph. And then we compared this to the special interest groups that were present at the conference. So here you see the special interest groups, you see knowledge discovery and machine learning, knowledge management, information retrieval and adaptivity and information systems. And here you see the different communities that were automatically detected. And what you can see here is that the smaller groups are quite well discovered in the contact network. So there's a lot of connections and contacts in these groups. In the knowledge management and the knowledge discovery special interest groups, there's some overlap in the automatically discovered communities, whereas the knowledge discovery and machine learning group, which was the largest special interest groups, is divided into different sub-communities. And if you look at these longer conversations, then you can also see that you get more fragmentation in this group actually. Some analysis which is also quite interesting or is about importance of people or their contribution that they do at a certain event. So we applied the system at a technology day, so this was kind of a project demonstration. And we had the project members and some members of the advisory board. So then we plotted the betweenness centrality, which measures the number of shorted paths through the nodes. So basically, this shows how distant you are from other members or how well connected you are there. And then we also plotted the eigenvector centrality. And this is a measure for indicating the importance of a node in a network, basically. Or, well, you get a better score for the eigenvector centrality if you're connected to important nodes. Let's put it like that. And then we saw, okay, the project partners, they have really direct connections to some central actors, which is good. So this was also good for the project. And on the other hand, what you see here is that the members of the advisory board, they somehow served as bridges between these different communities. So they were on the paths linking these different communities. So this is also kind of their role in this scenario. And now there's some interesting thing shown here. So there's Venus 1. So Venus was the research project. And you see that Venus 1 is really very important, and we are a very central person. And this is interesting. Okay, I will tell you something. I was this Venus 1. And the thing is why I'm up here. The reason is that I handed out the RFID tags. So I had a connection to everybody, basically. And this made me this perfect score in this on the right. Okay. As I told you, we can also focus on this contact graph or looking at longer conversations. Basically, what happens with the contact graph, of course, is that you start with the dense graph, and then if you concentrate on the longer and longer conversations, you filter out some conversations. So you start with all conversation or conversation lengths, then you say, let's say with a threshold of 5 minutes, you filter the small talk, and then for longer thresholds, you get only longer conversations. So the graph also splits up in different components. And we did this. This is one of our typical analysis directions. And then we checked this community structure again if you focus on more and more longer conversations. And we also, can also be observed as a proxy for some more important conversations. And this is a result from the Hypertext conference, where we focused on different partitionings of the participants. So according to track, according to country, according to affiliation, or according to the academic status. And what we see here is that for the track community, basically the community quality is the best, and it also increases if you focus more and more on longer conversations. So again, this here is the aggregated conversation length. Another interesting thing is if you do this time-based analysis, you can do role analysis. So you have different roles at some event. For example, there was a paper that described these different roles. You have big fishes. So these are the really important people. You have ambassadors. Ambassadors are important, and they connect communities very well. You have loners. So, well, loners are not so do not have too many contacts. And basically, we did this analysis, and here's a result of the ambassadors. And what you see here is that the ambassador role at the start of the conference is basically fulfilled by the organizers. So this is something that you would expect also with if you take into account all conversations. So including the small talk. So this includes all the situations when people go to the organizers and ask them, okay, where's the room, and so, something like that. Then, if you look at longer and longer conversations, you actually see that the professors become the ambassadors. So if you really look at the very long conversations, you see that the professors seem to connect different communities quite well. And this was quite nice, actually. Okay, now for some applications, what we did for recommendation, or we have a component in our system which is used for link prediction. So link prediction is you predict new links based on some network information that you have to predict which people will get in contact, and then you can use this for recommendation. So if you predict a link between two persons, then you can recommend the person to each other. And so basically you see the scenario here. There's some network structure, and then you want to predict the new links that will emerge in the network. And we did some analysis here. We applied a PageRank-based method, so we can also combine different networks. And this was quite interesting. When we apply the contact network of the conference alone, this already works quite well. However, there's a little trick, because you can basically apply this method if you have some data about the network structure. And what we did to improve on this situation, we used DBLP. So we used the citation network of DBLP, basically, between all the papers. And if we combine these two networks, this really helps to improve the performance of our predictor, especially for longer conversations. Again, you see here the time threshold for these longer conversations. We can also apply a similar technique for talk prediction. And for talk prediction, we created different networks, which are shown here. We had a presenter network. So we measured whether a participant talked to a presenter of a certain talk. We measured how the participants interacted in the coffee break before a certain talk. And we had a paper similarity network. And this contained all the papers for the participants that we got from DBLP. And then you can, based on the content of the papers, you can derive some network and some information, how similar are the research interests here. So actually, this is some kind of additional information like the DBLP citation network for the RFID network. And in this example, it also turned out that the combination of these different networks really helped for the prediction, also for the talk prediction. So in our scenario, the talk prediction was to split between basically two rooms. So we had, I think, 14 different talk pairs that we want to distinguish, and about 80 participants. And this combined analysis really did very well compared to the face-to-face contacts alone. Okay. Now to this last application example. We did some work on mining developer or experts profiles. So expert identification, as I said before, or the recommendation of experts is also very relevant in that area. So our setting was we want to find experts for specific questions or to get some overview in development areas. So basically relating to software engineering. And typically you do that using versioning information. So you get to your versioning system, CVS or SVN or whatever. And then you extract the lines of code that each developer has committed to a certain project, and then you say, okay, for a certain project or for a file, the person is an expert for this kind of project, or for the file if he has committed the most lines of code. But our hypothesis was that also this flow of information that happens between developers is relevant for that. So we wanted to capture or to include the face-to-face contact information. And in our experiments, this worked out very well. We analyzed our own software basically, so for the first version of Configurator, and we checked, or we wanted to find out the person that might help most with a specific module of the Configurator system. So, and for the different modules, it always turned out that the combined analysis or some network analysis of the communication and also the lines of code always outperforms the lines of code analysis. Okay, now I'll come to an outlook and some conclusion. For a summary, I showed you some approaches for mining these social interactions using ubiquitous sensors, so these RFID devices, which are able to capture these face-to-face contacts and also do some localization. And with this technology, we can really capture these social interaction networks at a really detailed level. For the analysis and applications, I showed you some basic analysis of the contact network, so some statistical properties, some role analysis, and this can also be used for link prediction and recommendations. So you can recommend talks or people that are relevant or interesting to participants of the conference. And in this way, mining or modeling the social interactions can be seen as a prerequisite for modeling human behavior, of course, because you're capturing this human behavior and in this sense of reality mining, that you're capturing information about the real world. And this also helps to reveal a better understanding of this collective social behavior with the face-to-face interactions. Let's say also this collective intelligence. So if you have the group behavior and they're doing a certain task together. And as an outlook, well, there are many, many more data-driven applications that you can think of using this technology or similar technology with the increased importance of ubiquitous and variable sensors. We are also doing some experiments with Bluetooth low energy, for example, right now, because there's you can also do some proximity detection with this Bluetooth stuff. But so far, the experiments are actually not so advanced, so still the RFID works best for the proximity detection. And we also want to apply this into more mobile and context-aware applications. And the goal or the idea here is also to include more of the online data. So we want to complement the offline with some online data. We can use this for self-monitoring, for example, for stress detection. There's an upcoming project where you can use the sensors doing stress detection for ambient assisted living. There was some project about helping dementia people for improving the situations or for some monitoring. And we're also using that for some educational data analysis project. Well, this is also some upcoming project. There's we were doing a study with psychology freshman students actually. And the good thing about psychologists is that they need to participate in such studies. So students get credits for participating in these studies. And there we monitored their behavior at a freshman's week. And then we want to kind of detect influence factors for study success and so on. So we're also complementing this with some subjective information from questionnaires and so on. So this is also quite interesting for us now. Okay, then thanks for your attention, and I'll be happy to answer some questions.